Welcome to the Explainer. Today, we're diving into the absolute next big leap in artificial intelligence. We are moving way beyond simple conversational bots and stepping into the era of fully autonomous, goal-driven AI agents. Now, if you follow AI at all, you know things are moving ridiculously fast. So today, we're unpacking exactly what makes these new agentic systems tick and why they're such a massive game changer. Let's get into it. So here's our roadmap for today. 1. Chatbots versus AI agents. 2. Perceive, reason, and act. 3. The power of memory. 4. Multi-agent systems. And 5. Risks and user experience.
Part 1. Chatbots versus AI agents, the core difference.
Okay, have you ever felt like your traditional chatbot is basically just a passive guess engine that completely forgets what you literally just said 5 minutes ago? Well, that is the classic non-agentic experience. It's passive interaction, incredibly short-term memory, and it's totally confined to a chat window. You type a prompt, it replies, and then it just waits. It doesn't do a single thing outside that little box. But AI agents, they shift us into a completely new paradigm, what we call a delegate user experience. These things are active goal seekers. They're equipped with long-term memory, and they can actually call upon external tools to, get real work done. We're moving far away from just chatting with a bot. We are now delegating complex, multi-step goals to a highly capable system.
Think of it kind of like this. A large language model, or LLM, is just the brain. It's a passive, probabilistic text predictor. The AI agent, on the other hand, is the employee. It's an active system that uses that brain to actually execute goals. So, while an LLM is totally isolated to whatever context you type into it, the agent has digital hands. It can query real-time databases, send out emails, and run tasks across the web completely autonomously. You don't need to hold its hand.
Part 2. Perceive, reason, and act. Under the hood.
So you might be wondering, how exactly do we give that isolated digital brain a functional body so it can actually interact with the world? Well, it boils down to this traditional agent architecture. Step 1 is perceive. The agent transforms raw environmental input, maybe that's text, an API response, or even audio, into a structured context that it can actually understand. Step 2 is reason. This is the cognitive core, right? The LLM evaluates that context and formulates a solid plan. And finally, step 3, act. This is where intention becomes reality. The agent executes its decisions via APIs, software tools, or hey, even physical robotic actuators. Picture a continuous, glowing flow of data pipelines, where the agent perceives its surroundings, reasons through its best options, and acts on the world.
The really crucial point here is how these steps are actually stitched together. And that brings us to the REACT paradigm. REACT stands for reasoning and action. It's this incredible framework where agents interleave think, act, observe loops. So instead of just taking a wild guess in one shot, they literally think out loud, they take an action, they observe the result from an external tool, and then, this is the magic part, they self-correct their plan based on that brand new information. It is step-by-step problem solving at its absolute finest.
Part 3. The power of memory, building context.
Now, without a solid foundation of memory, that entire think, act, observe loop completely falls apart. I absolutely love this quote from the source material. Agent memory is a computational exocortex. Without memory, honestly, even the smartest AI is basically just a goldfish. It requires this persistent memory management system to accumulate knowledge, adapt its behavior over time, and actually maintain conversational continuity. An agent simply cannot achieve a complex, long-term goal if it totally forgets what it did 3 steps ago.
To actually pull this off, engineers use 3 main types of agent memory. First up is working memory. This holds the immediate context of your current session. Second, we have episodic memory, which acts kind of like a digital autobiography. It records specific past conversations so the agent actually remembers that you asked it to prioritize direct flights last week. And third is semantic memory. This is structured world knowledge, facts, and relationships, which is usually retrieved via vector search. Try to picture these data blocks just snapping perfectly into place, giving your digital employee a massive, highly organized filing cabinet.
Part 4. Multi-agent systems, visualizing societies.
But hey, what happens when a problem is simply way too big for just one digital employee to handle all by itself? Well, we scale up. We orchestrate multi-agent systems, effectively forming a simulated agent society. Rather than forcing one massive program to juggle everything, you create a dedicated team of highly specialized experts. You might have one agent searching the web for information, another agent analyzing that data, and a third agent drafting the final report. All of them are communicating, negotiating, and collaborating within a shared virtual environment. It's honestly fascinating.
Part 5. Risks and User Experience Governance. Now, obviously, giving software the autonomy to take real-world actions introduces some very real-world risks. We're talking about opaqueness in reasoning, getting stuck in infinite loops, and the severe risk of sharing confidential data. I mean, just imagine an agent hallucinating and automatically emailing your sensitive financials to the totally wrong person. Yikes. To prevent these digital employees from going rogue, the mitigations we put in place are absolutely critical. We have to enforce human-in-the-loop approvals for any high-stakes actions. The entire user experience has to evolve so that the system treats you like a manager. It shows you its progress and explicitly asks for your sign-off before executing major decisions.
This rapid, almost unbelievable evolution leaves us with one incredibly profound question. As we watch these dynamic, tool-wielding agent societies evolve right before our eyes, moving from passive text predictors to orchestrated, active multi-agent ecosystems, is this the actual blueprint for artificial general intelligence? We're literally delegating reasoning to machines, and they are out there acting on it. Thanks so much for joining me for this explainer. Keep wondering, keep exploring, and I'll catch you next time.